Utilities on the tree should be naturally recursive because the structure for the general tree, as we explained before, is itself recursive. Let's see two examples over here. Number one is about how we can compute the node's depth given the node. And also the second one will be, given the node, we want to know what's the height of the subtree rooted at that particular input node. So these are the two definitions we already walked you through, but now we want to see how to implement them in Java. And let me just go directly to the iPad and go over these two methods quickly. And you can definitely look up the definition in the earlier part in the lecture. Okay, the first one here is about calculating the depth of a particular node. Let's look at the method here. So what we have is we got the depth method. Oh, where can you find the source code? For these two, you can simply go to the tree utilities class. You can see the tree utilities class itself is generic, and we got one method over here, depth, and also we got heights. It's important to know that we for any utilities method, we just define them under the tree utility class. And then in the test case over here, for example, you will have to create an instance of the tree utilities, and you can see over here. That's something you can definitely go over the test case yourself, but just remember this part over here, starting from here all the way until over here, we're doing some very similar setup for the references of the parent and children for the family tree that we spoke about in the lecture over here. It's going to set up this part over here. But for that part, I'm going to save our time by not going over them because we have seen some simple example already. So you should be able to understand exactly what's going on in the example test case. Let's talk about the depth over here. So the input is simply not just a tree node over here, right? Just any arbitrary node. Presumably the node is somewhere in the tree. The end over here could be David, it could be Ernesto, or it could be Elsa. It can be any of the nodes in the tree that we have constructed. And we got two cases over here. So in the base case, we say that if the parents of the node is simply just null, in that case, we are basically talking about the root over here. In that case, well, the depth of the root by definition would just be 0. So this part over here is really important to note. If a node's parent is simply equal to null, that means n is the root. And then by definition, its depth will just be 0. What about recursive case? If the node is not a root, in that case, we're going to recursively calculate the depth of its parents. Right? So you can think about the strictly smaller subproblem to solve. Smaller subproblem which is to calculate n.get parents depth over here. N.get parents. Right? And then we're going to say 1 plus. It's a very natural recursive pattern, which is to say, for example, if I want to calculate the depth of Vanessa over here, since I know Vanessa is not a root, because Vanessa's parents is not null, in that case, it's going to be 1, which will be the edge over here, plus the depth of its parents. Okay, let me write it down over here. And I'm going to trace the code together with you. And then I will tell you some little exercises you should really do on your own. You can think about Vanessa over here. Parents is not equal to null. Not equal to null. So that means the way we calculate it is by saying 1 plus. So the 1 is really the 1 over here. So this is the 1 edge to the parents. This is the 1. And then what about the subproblem over here, which I'm going to maybe use the pink over here. How about this one here? So this is a recursive call on some strictly smaller problem instance. In that case, it would be this part over here. And what we're going to calculate would be over here. This will be to calculate the depth of Vanessa dot get parents, which means we're going to calculate whatever the depth is for Elsa plus 1 with the edge, we get the depth for Vanessa. Right, that's the idea. And you can definitely see many test cases over here. You can see all the numbers over here. Right, so these will simply correspond to what we annotated just earlier when we introduced you to the idea about depth. Let me refer you to them. Exactly the D over here. right? So nothing is inconsistent. Everything's consistent, right? So what I want to do, just one more, is about tracing the code very quickly at a high level together with you, right? Let's now take a look. Basically, we are unfolding the recursion, like how we calculated the running time before for the binary search. Similar. Let's say we want to calculate the depth of Vanessa at the bottom over here. And if you run through this piece of code over here, we know that Vanessa.getParents is not equal to null. So it's not a base case just yet. So what we got to do is will be 1 plus the depth of Vanessa's parents, which will be Elsa. And it's always important to remember the 1 over here is really the edge from the node n to its parents. Let me write it down. The 1 over here is really the edge from n to its parents. This will be the most important insight to really see how this algorithm will actually work. Okay, let's now talk about this example by unfolding depth of Vanessa. By definition, it's going to be 1 plus, and we're going to make a recursive call. Let me use a different color. So it will be the depth of Vanessa's parents will be Elsa over here, right? Let me just box it better. Of Elsa. And how do we calculate the depth of Elsa? Elsa is also not a root. So by definition, it's going to be the edge from Elsa to her parents plus the depth of her parents. Let's now write this down. Okay, so it's going to be the 1 edge over here. And just make the plus 1 over here. Okay, let's now go back to the equation, which will be, don't forget the 1 plus from before, and this part here is going to be 1 plus the depth of Elsa's parents, which will be Chris. Let me just use a green over here. So this will be the depth of Chris. Is Chris the root? Apparently not. So we're going to apply the similar pattern for the recursive case again. The 1 edge from Chris to his parents plus the depth of his parents, which will be David, right? So we're going to say this 1 edge over here will be the plus 1 that we're going to write. Let's now unfold it further. So 1 plus, and also 1 plus, and also the 1 plus. Let's now do orange, the depth of Chris' parents, which is David. Are we now reaching a base case? Indeed we are, because you can see that David over here has no more parents. In that case, David will be the root, right? So this part over here, we cannot really unfold it further. We are done. So that'll be simply just 0. So this part over here is the base case, and the value would just be 0. And we can simply write down the final answer over here by calculating 1, 2, 3, and also 0. So the answer should be just 3. And notice I try to be very careful about the color annotation over here. So the plus 1 over here comes from the initial call, depth of Vanessa, which will go from Vanessa to her parents, Elsa. And the 1 over here comes from the first recursive call, when we want to calculate the depth of Elsa, in which case we want to calculate from Elsa to her parents, Chris, over here. And this plus 1 over here is corresponding to the second recursive call, in which case we are trying to calculate the depth of Chris, which will boil down into the edge from Chris to his parents, David. So that's also 1 plus, right? Just be careful about exactly how things are being how things are working. Alrighty, so that's about very detailed tracing for this recursive algorithm. It's pretty simple. I wouldn't say simple. It's pretty straightforward in some way to really see how the unfolding works. We'll see another one later. And little exercise for you. Let me choose one to assign to you. What about we try to trace, let's say, for example, Anna. I'll give you a simple one. How about this one over here? Try to trace about the unfolding of trace the depth of Anna. Right? It would be a simpler exercise than the one I did together with you, but just make sure you understand exactly how it works. It might appear to you as easy because I knew how exactly it works, so that's why it might appear as very smooth. But when you did it, I'm sure you might just run into some maybe confusion or doubts, in which case it will be time to reach out to me for help. Alrighty, let's now move on to the next utility.